Hi everyone, this is Intro to Orgo, an accompaniment to the note that I've posted online. The note's easier if you just sort of write out the steps and write out the rules, but now I want you to use those rules to put some pictures together. So organic chemistry is like a puzzle, and I love organic chemistry. My husband right now is calling me a giant nerd, but I don't care. I love a good puzzle, and that's what organic chemistry is like. It's like putting a puzzle together. So every little piece of the name is going to tell us a little piece of the puzzle. So I'm going to start us off with just some basics, and then we'll start getting a little more elaborate. So when we're drawing organic chemistry, carbon is king. So it's all about the carbons, and the hydrogens we will fill in as we need to. Every carbon needs to have 4 bonds, and so we'll be putting in enough hydrogens to make that happen. So there's lots of different types of pictures that we can be making. So I'm going to show you that to start off with, some simple pictures, and then we'll get into some more elaborate stuff. So the first one I'm going to show you is called a structural diagram. So I'm just going to make drawings that are 4 carbons big for each of these. And so if I were doing a structural diagram, I would join my carbons with single bonds. We're only starting with single bonds, so we'll be doing that for the next couple of days. So these are alkanes. Ane tells us single bonds. And then I would put in my 4 bonds total, but I would put in enough hydrogen so every carbon had 4 bonds. So the first one had 1 bond to carbon. It needs 3 more bonds, so I need 3 hydrogens. The second carbon has 2 bonds. I need 2 more to make 4, so it needs 2 hydrogens. Same with the third, and the last is like the first. So this particular picture is one that's easy when we get started because it's very visual and you can very quickly count to 4 and see how the diagram comes together. This is 4 carbons big, so if we were going to name this, we would use the prefix bute. It looks like but it's bute. And then the last part would be ane because we have single bonds. So bute means 4 carbons. Ane means single bonds. So this is a 4 carbon singly bonded compound. So we don't usually draw structural diagrams very often because you'll find that they take up a lot of space. So you're welcome to do structural diagrams, especially in the beginning, but you may find that, this has taken up all sorts of space on my page. Let's do something a little bit easier. The next one is called condensed structural. This is the one that I do most often, so I'm going to put a little star there just to sort of say that. And what I do is I still show my carbons bonded to one another. So my 4 carbons bonded to each other through single bonds, but then I tuck in the H's. So if I were doing this without having that structural diagram, I would count the number of bonds that the first C has. It has 1. It needs 3 more bonds, so then I would add 3 H's. The second C has 2 bonds. I need 4, so I'm going to add 2 H's. Third carbon has 2 bonds. I need 2 more, so I'll add 2 H's. And the last one has 1 bond. I need 4 bonds altogether, so I'm going to add 3 more H's. So I'm basically just tucking the H's in, and that's called condensed structural, and that's typically the ones that we will see. I'm going to show you 2 more that you might see as well. The next one is called condensed, and your textbook does this sometimes, and it just means you take out all the sticks. So for our butane, it would be CH3, CH2, CH2, CH3. So you take all the sticks out. Now this isn't too bad when it's simple, but when you have all sorts of branching and different functional groups, which we'll get into over the next few weeks, this becomes a little more complicated. So your textbook sometimes does this to us and it makes it more complicated, but I will typically do condensed structural. There's one other type that you'll see, and this is more advanced. You would wait until you were in university before you would use these, but I'm going to show it to you now because it is interesting and it's something that you're probably going to want to use, but you're not allowed to because we are not at the stage where we're that good yet. And this is what butane looks like as another condensed structure. The way it works is every corner or end piece is a carbon, and then the H's are implied. So I've got 1, 2, 3, 4 carbons, and then the H's are just implied. So it's very simple and very quick, but we're not at a stage where we're advanced enough to be allowed the privilege of doing these types of condensed structural formulas. You have to be a little more into your organic before you get this privilege, like I said, in university. So now that we've seen just a regular carbon chain, let's get into some branched chain alkanes. And that's where we have a set of rules from today's note, and we're going to use them to help to draw and also to name. So naming is probably the harder of the two. Drawing is probably the easier of the two. And the reason why is because when you draw, you kind of get to decide where things go. Whereas when I draw stuff, sometimes it gets complicated because you have to make decisions. So let's practice naming first. I lied. We're going to practice drawing first because it's the easier of the two. So I've got a 2-methyl pentane. Every piece of this word is telling us a piece of the puzzle. So let's see if we can work it out. I'm going to start writing some stuff down below. This is where I would start. Pentane. So pent means 5 carbons. Ane means singly bond those. So I always start with this part of the name. This part of the name at the end here is called the parent chain because it is the longest carbon chain in a row that we're going to have in this puzzle. So you're going to see if we're drawing or naming, we're always going to start with the end of the name because that's the sort of basics. So 5 carbons in a row, 1, 2, 3, 4, 5, singly bonded. That's the starting point. All right, now I'm going to deal with methyl. Meth means 1 carbon. And the while ending tells me it's a substituent, meaning it's hanging off this 5 carbon chain. Where is it hanging? That's what the 2 is for. So the 1 carbon chain is on the 2nd carbon in the pentane chain. So if I were to number my carbons, I can number from left or right. Because I'm doing the drawing, I get to decide. I usually number from the left, but it makes no difference. So the 2nd carbon in is where this action is happening. I've got 1 carbon big, a methyl. So I'm going to do a bond to a single carbon. That is now what we call our carbon skeleton. So this is 2-methyl pentane. The only thing missing now is the H's. I've got all the other pieces that we need. So let's put some H's in. Again, the H's, you've got like a whole bucket full of them, and you're just basing them around the fact that every carbon needs 4 bonds. So the first carbon that I've labeled here has 1 bond, it needs 3 more. I'm going to tuck them in. The second carbon has 3 bonds, it needs 1 more to make 4. The one at the top has 1 bond, it needs 3 more to make 4. Over to the right of number 2, so the number 3 carbon, I didn't put the numbering because we didn't really need it, but number 3, I've got 2 bonds, I need 2 more. 2 bonds, 2 more, 1 bond, 3 more. So there is my 2-methyl pentane complete. You just made your first branched chain alkane. Yippee! Let's try another one. All right, we're going to try a 2,3-dimethylhexane. Again, I'm going to start with this part of the word right here. Hex, if I go to my table, means 6 carbons. Ane means singly bond them. That's the starting place. 1, 2, 3, 4, 5, 6. Now I'm going to put in some of the fancier stuff. So over here I have a methyl. Methyl means 1 carbon big. While tells me it's hanging off the parent chain that I just drew. And the di means I've got 2 of them. Where should I put these 2 1-carbon chains? Well, that's what this is for. That's your location. So I'm going to number from the left. Again, you can number from the right. Doesn't matter. 1, 2, 3. You can number all of them if you want, but really we just need the 2nd and the 3rd one to be labeled. And on the 2nd and the 3rd, I have 1 carbon chains. There's 1 carbon chain there, 1 carbon chain there. I've drawn them both in an up position, but up and down doesn't make a difference if you have single bonds. Single bonds rotate freely. So I could have drawn 1 up, 1 down. I could have put them both down. It doesn't really matter. Let's put in my H's again, 4 bonds total. So I've got 3 here, 1 here, 3 there, 3 there, 1 there, 2, 2, and 3. All right, let's try making some names now. All right, so take a moment to copy this into your note, and we're going to solve it using our strategies for naming compounds. This is a little bit different than doing our own drawing because when we draw, it's easier. We get control over where things go. Here, it's been drawn for you, and you're at the mercy of where I've drawn things. The very first step though, just like when we were naming, I have to, or drawing rather, the parent chain is the key. So I'm looking for the longest amount of carbons in a row. So I'm going to show you how we would do this. Normally it would be right through the center. And let's see, we've got 1, 2, 3, 4, 5 through the center. But there are bends in the chain, just like you can have bends in a road. So I'm going to show you a couple of other strategies or options here. We could have gone 1, 2, 3, and we could have gone up here 4, 5. And that's also an option. That's not the one we're going to use because it's still 5, and the green one is easier to see. Let's try another one. I could have started down here. 1, 2, 3, 4, 5. Same length, so still part of a parent chain. All of these are actually going to end up being the exact same, but again, the yellow is not as easy to see as the green, so generally I wouldn't choose that. I could also start at the bottom and go up here, and that's also 5. So again, so long as I'm not making anything bigger than 5, I'm going to stick to this green one because it's the easiest one to see. The green one is the parent, so let's name this in stages. The parent then is going to be called pent, because there are 5 carbons, ene, because they're singly bonded. So 5 carbons, single bonds. All right, I've got 2 substituents here, 2 things hanging off. The top one has 2 carbons. So a 2 carbon side chain is called eth. And the part that says it's a side chain is the YL ending. So this side chain is called an ethyl. Eth means 2, YL means side chain. Down at the bottom here, we've seen this guy before. This is a 1 carbon side chain. Our word for 1 is meth, and our side chain is YL. So this is a methyl group. So we've got ethyls and methyls. One thing that I should just mention here about our prefixes for carbons. You've seen a lot of them before with covalent bonding, but the first ones are new, and we sometimes, so our methyl, ethyl, propyl, butyl, we sometimes use monkeys eat peeled bananas as a way to remember those 4 new ones, because that's how they start. All right, so we're going to put it all together, and we have to put it in alpha order. That's the last rule when we're doing a name put together. So the pentane is the very last thing. If you want, you can build from the back. Pentane is the end. And then we're going to put it in alphabetical order. So ethyl will go before methyl. And before we put it all together, we have to number our carbon chains so we know where these substituents are going to be. So in the name, I can tell you. So I can number from the left or from the right, but my rule is always give the substituents the lowest possible location on the parent chain. So the substituents are hanging closer to the left, so I'm going to number from the left. So 1, 2, 3, 4, and 5. So let's put it all together now. So I've got a 3-ethyl. I always use a comma or a dash between numbers and words. I now am going to add the number for methyl, so I'm going to use another dash here. There's our 2-methyl. And we don't use spaces between words, so you'll notice that I didn't quite space this properly. I could have left my pentane to the end, but I decided to put it in first. I'm just going to cheat, and you're welcome to do the same thing. I'm just going to make it look like cursive writing here, and I'm just going to pull it across to the pentane so it looks like one big word. So this is a 3-ethyl 2-methyl pentane. That's how it would be pronounced. All right, let's try another one of these where I'm drawing and you're naming, because these ones, like I said, can be tricky. Now again, typically the longest chain will run right through the center. And let's count them. 1, 2, 3, 4, 5, 6. So 6 looks like the longest. But there's these side chains I have to take into account. So I'm going to do them in yellow, and I'll see if I can get anything bigger than 6. So for instance, I could do this and go up here. That's 1, 2, 3, 4, 5. So that's smaller. No big deal. The same thing would happen at the bottom. The other option is I could do something like this. Let's just see, I've got 1, 2, 3, 4, 5, 6. It's the same as the other one, so let's stick with the green one. Again, it's the easiest one to read, so let's keep it as simple as possible. So here's my green chain. My green chain is 6 long, so it is a hexane. Again, hex means 6 carbons. Ene means they are singly bonded. Now I've got some substituents, some things hanging off the parent chain, and by circling the parent chain, they're very obvious, which is why I do it this way. At the top there is a 2-carbon chain. We've seen this guy before in the last example. 2 carbons is eth, and because it's a side chain, we give it the YL ending. I've got another one down here. This is also a 2-carbon side chain, so this is also an ethyl. It's not called a butyl because the 4 carbons are not bonded to one another. They're 2 separate side chains. One's up and one's down. So I've got 2 side chains that are the same, and then my hexane. The last thing I need to do is number my chain. And again, remember my goal is to get to the substituents as quickly as possible. The substituents are hanging closer to the right-hand side this time, so when I number my chain, I'm actually going to number in this direction. And now I'm going to put it all together. So I've got 2 ethyls, and they're both on the number 3 location. So locationally, it's going to be a 3. Because there's 2 of them though, I'm going to give each one its own number. I'm not going to say just one number for both. I'm going to say 3, 3. That means everything that's going on the 3. Then I'm going to have a dash because I'm going to put some letters in. And I'm going to use a die in front of the ethyl. So why am I using a die? Die is telling me, I can't make a dot for some reason. Die is telling me times 2 of the ethyls. So that's exactly what this picture is. It's 2 of the ethyl group, so diethyl. And then I'm going to add my hexane as my parent chain because it always goes at the end. Okay, let's try another one. All right, we've got a big one here, but again, all the rules apply. So the first rule is find your longest chain. So again, that longest chain is going to be right through the center, like it most often is, but again, not always. So we'll see some examples coming up of where there's bends in the chain. So once I circle that, you can very clearly see our substituents. I've got one up here, 1 carbon big, which means it's a meth, and it's a side chain, which means it's a methyl. I've got the same 1 carbon chain down here, so this one is also called a methyl. And then I've got a 2 carbon chain up here, which means this one is called an ethyl. My substituents are hanging closer to the left, so I'm going to number from the left. 1, 2, 3, 4, 5, 6, 7, and 8. And I'm going to put it all together. Again, I'm going to go in alphabetical order according to substituent name. So ethyl goes before methyl. So I will have a 4-ethyl. Then I will have a dash because I'm going to put some numbers in, some locations. I've got a 2, 3. I'm going to group my methyls together, and I'm going to group them to become dimethyl. Remember, di means you've got 2 methyls. And then I'm going to put in my 8 carbon parent chain, which is an octane. So again, let's just break it down. This is a location for your ethyl, and ethyl is a 2 carbon side chain. This is your location for your methyls. Di means times 2, and methyl means 1 carbon side chains. Oct means 8 carbons in your parent, and ane tells you you're going to singly bond those parents. All right, let's try another one. All right, this one doesn't look quite as complicated, but I will tell you there's a little bit of a trick to it. So the first job, as always, is circle your parent chain. So you're looking for as many carbons in a row as you can find. And if you do this properly, you should also be circling this one that sticks up. And that's an important piece here because sometimes it looks like that last little bit is not part of it. But if you were to end your chain here, that chain keeps on going. So that's not accurate. We have to include that last little bit. So that is my parent chain right there. So things that look like substituents on the end sometimes could be an extension of the parent chain. It's like if I had my arm straight versus bent. You wouldn't stop counting it as part of my arm just because I bent my arm. So longest carbon chain in a row. So now that I've circled that, it looks like my substituents, I've got a 1 carbon here, so that's my methyl. I've got a 1 carbon here, another methyl. And they're hanging out mostly to the right, so let's number from the right-hand side. If you weren't sure, you could always number in both directions, because sometimes it is tricky if it's a big chain. And let's put it all together. So I've got a 2, 3 dimethyl hexane. Again, breaking it down, di means times 2, methyl means 1 carbon side chains, and then 2, 3 tells me where to put them. Hex means 6 carbons, enes means singly bonding them. All right, let's finish off with just a couple of ones where you're drawing. We'll go back to that, and then you're onto some homework. So you're going to draw for me a 3-ethyl 2,2-dimethyl nonane. And again, we've been doing a lot of naming so far. So going back to drawing, remember we're still starting with the parent chain. So you're going to start with a nonane. Nonane, no means 9 carbons. Ane means singly bonded. So let's put that together. 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. Now we're going to start putting in our substituents. And you can start from the left here. So you could start with your 3-ethyl if you like. And you can put the numbers in if you want, or you can just go ahead and make them. So I'm going to count from that being my number 1. So over on the third one will be an ethyl. Remember, ethyl is 2 carbon side chain. And again, I can put this up or down. It doesn't make a difference. Over here for the second one, I have a 2,2. So the action's happening on the number 2 location down here. And I have a dimethyl. So di means times 2, methyl means a 1 carbon side chain. So I'm going to put one of them in the upward position, one of them in a downward position, just so they're not mixed up with each other. After that, I've got all my pieces. So now it's time to put in my H's. Remember, the goal is 4 bonds. So you always count how many bonds you already have, and then you add the appropriate number of H's to get you to 4. So I'm going to need 3 here, 3 here, 3 here. This center carbon, the number 2 carbon, doesn't need any H's because it's already got 4 bonds. So going over here, I just need 1 more, 2 more, 3 more, 2, 2, 2, 2, 2, and 3. So I think we'll wrap it up there. You've seen lots of examples at this point. It is tricky business for sure. I'm going to give you a worksheet to try for the next couple of days. So our focus for the first part will be just the top where you are going to make the drawings. And then for the second day, we'll focus on the bottom where you are going to be making the names. As always, there will be a homework sheet posted and I encourage you to use it. Ask for help. I'll take up as many questions as we need. We want to make sure we have a really nice foundation for this part of the lesson. Organic chemistry is like a snowball going down a hill. It is going to constantly get bigger and bigger, and we're going to keep adding as we go. So it's really important that you work in real time. Yeah, get help when you need it. Ask questions. That's what I'm here for. So take advantage.